Hi, this is Leetcode question, design memory allocator. This is the third question of weekly contest 323. You are given an integer n representing the size of zero indexed memory array. All memory units are initially free. You have memory allocator with the following functionalities. Allocate a block of size consecutive free memory unit and assign it to the ID. Free all memory units with the given ID. Multiple blocks can be allocated to the same ID. You should free all the memory units with the ID, even if they were allocated in different blocks. Implement the allocator class. Allocator take in, initialize an allocator object with a memory array of size n. Integer allocate, take size and ID, find the leftmost block of size consecutive free memory units and allocate it with ID. Return the block's first index. If such block does not exist, return -1. Then we have this function return integer free all memory units with the ID and return the number of memory units you have freed. So this is our memory, and this is the example given in the question. The memory contains 10 elements as given in the allocator constructor, and these 10 elements are free, so the whole memory is free, and we know that by checking the value of every index from 0 to 9. The value equals 0, and 0 means it's free. Now suppose that before solving this example, suppose that we want to allocate 3 elements and assign them to ID 1. How can we do that? So we have a counter equal 0, and we need to iterate over the elements from left to right, so I equal 0, and we need to check if it's free. If it is free, we increase the counter, so this become 1, and 1 is still less than 3, so we go to the next element, I equal 1. Now this is also free because the value is 0, then we increase the counter, become 2, 2 is still less than 3, then I become 2, we check it's free, then we increase the counter become 3. Now we have 3 and 3, and this means that this is a valid block. Then we need to loop back three items starting from this index I2 until I minus 3 plus 1. That means we need to count 3 elements in reverse, and while looping back we will assign the ID 1. So I equal 2, it will take the value 1, it will be assigned to the ID 1, then we increase it, so this become 2, then our index here, we assign it this, then it's become 1, and I become here, so we assign it this ID, this is 0, and we exit our loop, and we return this index. While looping back we reach to this index which is 0, so we return 0. Notice that if while looping from left to right, if the element, assume this is 1, so the counter equal 0, we check the first item, so increase it to 1, then this one is already assigned to some ID, and that means that we have to reset our counter to become 0, and we move to the next item, and it's a free, then to the next one it's free, then to the next one it's free. So this is 2, this is 3. Now we know that this is our block. Then we need to loop back, and for the 3 items we assign it the ID, and we return where we stop. So this will be our algorithm for allocation. So the first method, allocate, and size 1 and 1, so this is size 1, and we will return 0, and this will be assigned 1. So this index is 0, so we return 0. 1 2, we loop from here, the counter becomes 0, but this is blocked. Then we come here, this is free, and the counter become 1. So this equal the size of the required block size, and we assign this to 2, and we return the first element in, or the first index of this block, which is 1. So the answer is 1. Then we have allocate 1 3, the same, this 3, and we return 2. Then we have allocate so this is allocate for this one, this allocate for this one, and this allocate for this one. Then we have free 2, and for free we will go over the array from left to right, and we check every ID if it equals to the given ID 2, and if it is equal if the value equal to the given ID, we have sum, and which equals 0. So if it equal to the ID, we will increase it by one every time we visit a node or a cell that has that ID. So in this case, we come to this index, the value of ID is 1, so we don't do anything. 2, we added by 1, so sum equal 1. 3, it's not equal to 2. 0 0 0 0 0, so we return 1, and this will be the answer 1. Then we have allocate 3 4, and our counter equals 0. This is blocked, or this is assigned. This is now remember we freed when we freed this 2, we also put it to 0. So this is counter become 1. 1 is less than 3. Then we go to this is assigned, we reset the counter again, c equals 0, and come here, c equal 1, here c equal 2, here c equal 3. So we have this block, and our I is here. We loop 3 items back until we reach to this, and while we looping back or iterating back, we assign it the proper ID, which is 4 4 4, and while looping back we stopped here, so we retain the index 3. This is the answer 3. Then the next query is allocate 1 1. So come here, this is assigned one, this one is free, so we assign this to 1. So now we return this index, which is 1. This is the answer. Then we have allocate 1 1. So the first freed cell is here, because all of these cells assigned an ID, and we assign this 1, and we return this index, which is 6. Then we have free, the free for 1. Again, we have sum equal 0, and we need to free all the index or the elements that has the ID 1. So we loop from left to right. This index has the ID 1, so we increase the sum by 1, and we free the memory by setting it to 0. Then this also set it by 0, the sum become 2. This is 3, this is 4, 4, 4, this is 1. We free this memory, and the sum equal 3. Then we return 3. Then we need to have a block of size 10, assign it to ID 2. So our counter equal 0. This is free, become 1. This is free, become 2. This is assigned, we reset the counter 0. Then this is assigned 0. This is assigned. This is a free, so 1. This is a free, the counter become 2, free, 3, free, 4. But we ended our memory and the size is less than 10, so we break here and we return -1 because we couldn't find a block of this size. Then we have to free this, all the memory assigned to this ID 7. So again, sum equals 0, and we loop from left to right and see if there is element with ID equals 7, and as you can see, there are no elements with this ID, so the answer will be 0. Let's look into the code implementation. So here we have the memory, and in the constructor we assign it or resize it to the number of elements given in the constructor. Integer allocate size and the ID. This is our counter, and this is the index for iterating over the elements from 0. And as we said, if it's a free, we increase the counter, else we will set the counter to 0 and start again. If the counter equal to the required size, we break. And here we check if counter equal to the size, means that we found a block, and we need to loop back with the number of elements equal to C. So we keep looping, and while looping back, we assign the proper ID to every cell, and we return -1 if C is not equal to size, and we return I+1 if we found the block, while I+1 because let's say we start from here and we need to do 2 items, so I is here, then I become here, then I come here. We break the condition, but the index we need to return is this one. Then for the free function, we loop from left to right, and we check if the element equal to the ID. we free the memory in that index, and we add 1 to our answer, and we return the sum as final answer.